Hey guys, Anisha's PyMasters Colors here. So today we have another data structures lesson over stacks this time. So stacks, kind of like lists or just other linear data structures. The difference between stacks and lists though is that stacks have fewer operations and they access elements based on recency. So unlike a list, stacks don't have indexing. So in a list, you can access any element in a list no matter where it is, depending on its index. However, stacks do not have that property. Stacks can only access elements based on recency, meaning based on what element is at the top of the stack currently, and whatever element is at the top of the stack is decided by when it was added in relation to the other elements in the stack. So specifically, stacks follow a rule called LIFO, last in, first out, which basically means that the last element you put in the stack is going to be the first one that you're able to access and also the first one that you would be able to remove. So it's kind of just like a stack of papers. When you have a stack of papers and you add a paper to the stack, that paper is going to be the new top of your stack. And whenever you remove a paper because you need it, you're going to remove the top paper of the stack. And if you want to remove the bottom paper of the stack, that means you have to remove all of the papers above that, and then you're going to remove that bottom paper. So the top paper of the stack is going to be the first one to be accessed. The bottom paper of the stack is going to be the last one to be accessed. The same thing here. The top of the stack is always going to be the first one to be accessed or to be removed. And so the uh, layout of a stack kind of looks like this right here. So let's say we appended elements to the stack in this order: 1, 2, 3, 4, 5, 6. So let's say we appended element to the stack in that order from left to right. Then 1, which was the first element that we appended to the stack, that will be our bottom of the stack. And 6, which is the last element we pushed onto the stack, that's going to be our top of the stack because it's the last element that we added to the stack. So that's going to become our top. So whenever you add an element to the stack, it's going to become the new top of your stack. When you add another element, that element's become the new top of your stack. The first element you add is going to be at the bottom of your stack, and then whenever we try accessing elements, we're always going to access from the top. So 6 would be the first element that we would access when we run an operation on the stack. So there's 5 main operations that stacks can perform. The first one is peeking. Peeking is just accessing or returning the top element of the stack. So if we were to call peek on this stack right here, 6 would just be returned. It wouldn't be removed, but it would be returned, so we could use it, we can access it. Pop is similar to peeking in that it also returns the top element. The only difference is that it also removes the top element. So peek only returns the top element, pop returns and removes the top element. And then there's push. Pushing is just appending or adding an element to the stack, and then when you push that element onto the stack, that becomes our new top of the stack. So if we were to push 10 onto the stack here, that's our operation, pushing 10, then 10 would be added to the top of the stack. We only add to the top of the stack. So if you were to add a paper to another stack of papers, that paper would become the new top of the stack. And then the next one is empty. Empty just checks whether the stack is empty or not. So for example, if we were to call an empty operation on this stack, it would return false because there's still elements in the stack. If there's no elements in the stack, empty would return true. And then there's size. In a stack, size is just going to check how many elements are in the stack. So if we were to call the size operations on this stack, it would return 7 because there are 7 elements in the stack. If the stack is empty, it would return 0. So how do we actually implement a stack in code? The best way in Python is to do it through a list. And the reason why is simply because of how lists work in Python. The append method for a list adds elements to the end of the list. So then we can treat the element at the end of that list as the top of the stack. The pop method, there's already an inbuilt pop method for lists in Python that just removes the last element, or we would consider it as the top of the stack, that removes and returns it. And then peeking can then be done by indexing just the last element, because remember, stacks can't index the middle of the stack. So in order to in order to get around that, we can just only index the last element. Since lists don't have an inbuilt peaking method, we can just use indexing and access the last element using index -1. And then for empty, we can just check if the size of the list is 0. And then for size, we can just return the length of the list. So now let's actually implement a stack in code. So the way that we're going to create a stack is we're going to use user input. We're going to ask the user for values to add to the stack until they're done adding values. So first, let's create our stack. So we're just going to initialize the stack variable to an empty list for now. And then we're going to prompt the user to add values to the stack. So we're going to ask the user what values they want to add to the stack. So we're going to get whatever input they enter for the question or for the prompt. Enter the first value of your stack. And we're going to take whatever they enter, which should be an integer. This should be a stack of integers. We're going to take whatever they enter, and we're going to cast that to an integer because Python returns a string for whatever the user enters for the input method. We're going to cast whatever they enter to an integer. And then we want to keep doing this process. We want to keep prompting them. We want to keep prompting them a value to add to the stack, and then we want to stop when they enter something like a certain integer that we're going to say is -1. So when they enter -1, that's when we want to stop prompting them to add values to the stack. So we're going to have a while loop, while, and we have to store whatever is returned here in a variable. So we're going to call that variable value. So whatever value they enter, we're going to store that in the variable value, and then while value is not equal to -1, we're going to keep this process going. So while value is not equal to -1, we're going to add whatever they enter to the stack. So stack dot append value. It's going to be the appending method right here that we're going to use to push elements onto the stack for Python lists. And then once we append the value, we're going to prompt them again. So we're going to ask them that same question, but enter the next value. And then they're going to enter a value, and then we're going to validate, make sure that that value is not -1. And then if it's not, then we're going to add that value to the stack, and then we're going to prompt them again. And we're going to keep doing that until they enter -1. So now we should have already created their stack. So the next thing to do here is to actually show the stack operations one by one. So first I'm going to print their stack. We're going to print their current stack with a label. And then with whatever their stack currently is. And then I want to identify the top element of the stack. The way I do that is by peeking the stack, so by accessing the last index of the stack. So the top should be equal to the stack, and then at the index -1, because the append method in Python it adds elements to the end of the list. So that element at the end of the list it should represent the element that was most recently added to the list. So basically, it should represent the top of our stack, so we can access that element by accessing the last index of the list, or list index -1. We're going to print out whatever their top of the stack is. Top of their stack, which should just be top. And then now we want to remove an element from the stack. So we're just going to now pop the stack, and we're going to show them whatever element was actually removed. So popped label right here, or we'll just say removed. And it should just be the top of our stack that's removed. So whatever was printed previously, that should be that same element that's removed. And then we're going to do stack.pop. So Python lists already have an inbuilt pop method. And then the next thing is we want to now print the new stack after we remove that top element. So print the new stack label, their new stack. And then we can print the size of the stack as well. So the size of stack would just be the stack and then, or it would just be the length of the stack. So we use the len function right here to get the length of the list of the stack. And then we can run our code, see if it works. Just take out the identifier there. So the first value of our stack we can have it as 1. Next value can have 2, 3, 4, 5. And then once I've added my first 5 values, I don't want to add any more, so I can enter -1. And then it'll show me my data. So the current stack is 1, 2, 3, 4, 5. The top would be 5. Whatever I want to remove is going to be 5. The new stack is just going to be uh, that top of the stack, which should be 5 right here. That top removed, so 1, 2, 3, 4, excluding that 5, because that's what's removed. And then the new size of our stack would just be 4. And I just have a colon there. So yeah, that is essentially how stacks work in Python. So that's how we just implemented a stack using a user input right here. If you want to iterate through a stack, all you have to do, you can use a for each loop. You can't use indexes, like you can't index each element. You can't use their indices because the stacks don't have indexing. But you can still use a for each loop or an enhanced for loop to iterate through each element of a stack. So we can say for element in stack, so for each element in stack, and then we can print the element with a space after it. So just like that. So once we've already removed everything off our stack right here, we'll delete all of those operations. So just like that, we have printed the values of the stack. And then if we want to iterate through each element of a stack and move all the elements to a new stack, what you could do is I'm going to have to create a new stack here. So we'll say stack 2 is equal to a different stack, or a different list. And then what I could do is, so if I wanted to reverse the original stack, what I could do actually is I could just do while, and then while the length of the stack is greater than 0. So basically, while the stack isn't empty, I'm basically going to take each element from the stack. I'm going to remove each element from the stack. So stack.plot. And then whatever value I remove, I'm going to add that to the new stack. Take out the identifier here. And then I'm going to print the new stack. So we'll print the old stack. And you see how the new stack is just a reversed version of the old stack. And the way this works is just through the stack's LIFO method, or the stack's LIFO rule, where the top of the stack, the top of the stack is going to be the first one that's going to be accessed. So when we add all of the elements from the previous stack to the new stack, we're going to access by the top of the stack first. So that top of the stack is going to be the first one we access and then append into the new stack. And then the new stack will contain the top element as its first element. And then the bottom element of the original stack is going to be the last element we add to the new stack. It's going to be the last element that we actually access. So then that's going to be the top of the new stack. So then that's why when you remove elements one by one from a stack and you add it into a new stack, the new stack is actually just going to be a reversed version of the old stack.